All right, for this free response question, number 9 from the Barron flashcards, third edition. This is a little bit of a tricky problem, so I'm going to talk you through it. So you have a statistics teacher here who they want to figure out the proportion of students who have cheated on an exam. They figure if they ask a student, even if they're just giving them an anonymous survey, some students might not be truthful because they think they might be identified, whether it's handwriting or the order that these things are collected in. So this teacher plans a non-standard procedure. She randomly selects 400 students, and then among the 6,000, she's going to give them these instructions. Flip a coin. If that student flips heads, they'll automatically answer yes. And if they get tails, they will answer truthfully as to whether or not they cheated. So that way, if the teacher's looking at these responses, they see a yes answer, they wouldn't necessarily identify that student as a cheater because there's a chance that that student could have just flipped heads and then just answered yes. So that kind of covers the student in case they're worried about getting caught for cheating. And maybe they'll be more truthful. So part A here asks us to pick a simple random sample of 400 students. Nice and easy. You got 6,000. I'd say assign them all a number and then use a random number generator to pick 400 numbers and then use the 400 numbers, that correspond to those students. Use them in your survey. Nice and easy. All right. So now we have how many students would be expected to answer yes because the coin flip landed on heads. Okay, so here's how you want to look at it. You got 400 kids or 400 students who are taking this survey, right? When you're flipping a coin, and you're assuming it's a standard coin, right? You have a 50% chance you're going to get heads, 50% chance you're going to get tails. So they're asking how many would be expected to answer yes? Well, I know I'm looking at a binomial distribution here because let's see. Do I have a binomial situation or is it binary? Yes. You either get heads or you don't. Independent? Yeah. Coin flips aren't going to be affecting each other. Number of trials? Necessarily? Yeah. In this case, I got 400. 400 coin flips are going to be happening. And I have a probability of success, which is going to be 0.5. So if I have 400 kids flipping coins, I should probably expect 200 of them to be getting heads. That's all we're really looking for here in part B. And that's, all you really do here. Take that 400 total, probability of them getting heads, 400 times 0.5 gives you 200. Okay. So then in part C, we're taking a step further. Suppose 285 responded yes. Based on this sample, what is the point estimate for the proportion of students at the college who never cheated on the exam? Here's what I would do. I'm going to take that 285 who answered yes. I'm going to subtract the 200 out of them that I expect got heads. Because remember, if they flipped heads with their coin, they're going to circle yes no matter what. Which means, if I take away those 200, I can jump to the conclusion that 85 of these yeses are truthful, and 200 of them are just people who flipped the coin, and then they answered yes because they got heads. So that's why the statistics teacher did this, because using this, they can use that expected value of 200 heads and then get a good idea of how many students actually answered yes because they were being truthful. Now you want to remember he did a survey of how many? 400, right? Out of that 400, right, we are going to assume that how many of them flipped heads? 200, right? So I'm going to take them out of there. Those 200 who flipped heads, I'm going to take them out of the equation. That leaves me with 200 students who probably answered this truthfully. Now, of course, this is all based on kind of what we expect for our values here. We have no real way of knowing if all 285 of these students who answered yes, if, only 85 of them were being truthful. Who knows? Maybe only one kid flipped heads and had to answer yes. We don't know this. But we can kind of make this guess based on the fact that we'd expect 200 kids to be flipping heads. And again, we take them out of our sample here because we'd assume, well, they're going to answer yes no matter what. There's no point in having them in here. Now that I have a proportion that I can work with here, is a nice point estimate, now I can calculate a confidence interval. So remember, a confidence interval. Now, first of all, I'm going to change this to a proportion, make it a little easier. 0.425. So I'm going to use that 0.425 as a point estimate to figure out what proportion of kids on campus have actually cheated. So I'm going to use that point estimate. My statistic here is 0.425. And I'm going to use that as a point estimate to build a sampling distribution. I want to figure out where 90% of these statistics are going to fall. Am I correct? Yep, 90%. Which means on each tail, I'm going to get 5%. So I got to figure out how many standard deviations do I have to go out from my center to capture 90% of all these statistics. Here's what you can do. Inverse norm. Plug in an area of 5%. Mean of 0 because we're dealing with z-scores. And standard deviation of 1 because we're dealing with z-scores. If you plug these values in, you will get yourself 1.64. Which means you have to go 1.64 standard deviations less than the mean and 1.64 standard deviations more than the mean, and this will give you 90% of all the possible statistics based on our point estimate here. So now I can create a confidence interval. So I'm going to take that 0.425 plus or minus 1.64 times, let's see, I've got 0.425, and then the complement of that would be 0.575, excuse me, over my sample size, which would be out of 200, because remember, up here, I took away the 200 that I assumed to be flipping heads, because the thing is, I don't want to include them, because if they're flipping heads, then they're not telling the truth. They're just answering yes because the coin told them to. I'm hoping that the 85 here, out of 200, they were the ones who are answering truthfully here. So now they have these numbers, I can construct a confidence interval. So you can use your calculator to figure out your margin of error. Remember, this whole thing here is your margin of error. So I'm going to do 1.64 times square root of 0.425 times 0.575 divided by 200, and I get 0.057. So, whoops, wrong tool. Plus or minus 0.057. Alright, so I'm going to subtract that and I'm going to add it. And I get a proportion right now of my low end is 0.368. I'm going to add that now, 0.425, plus that 0.057, and I get 0.482. So now I can say I am 90% confident that the true proportion of students on campus who have cheated, and I'm just going to narrow down my statement here, but you get the idea. Of students who cheated is between about 36.8% or 0.368 and 0.482. What I'm not going to include here, which typically are included in confidence intervals, but it's really important to know, is that I'm also 10% confident that the true proportion of students who cheated is outside this interval. So I'm 10% confident that it's either going to be less than 0.368 or greater than 0.482. But here we go. This is how we constructed this confidence interval. It was a bit tricky. First of all, you had to figure out how to design your sample. You had to figure out the expected value, which again, I did it based on it being a binomial distribution. Went with expected value. Figure out my statistic. I just took away the expected number of kids I expected to flip heads and would be answering yes no matter what, because I don't want them. I wanted the kids who are probably telling the truth. And then once I got that proportion of students who were telling the truth, that's when I built my confidence interval, just like this. Hopefully this helps. This was a tough question, but hopefully my explanation and walking through it helps you understand it a little bit. Again, if you have any questions, you can email me at statsgamash@gmail.com, or you can email me at my school address.